assessing trends, not accessing, assessing trends. So now we have some data here. And so we have some interesting data like, okay, cool. Is there a trend in here? Maybe, I don't know, right? So this is where we can start saying, well, okay, what we want to do is actually find trends and basically, either way I imagine is breaking down our data away from that trend, okay? So one thing we can do is say, well, we can do rolling statistics. And so rolling statistics is kind of like taking the average over the past period of time and subtracting off that point. So one thing, for example, like, you say, well, okay, like, for example, if the stock market, let's just pretend the stock market is at a high point, right? It probably the next day, it's probably not going to suddenly drop down very quickly. It's probably going to be about at that high point, right? And then maybe the next day, it might be about that high point too, but maybe a little lower and stuff like this. So rolling statistics allows us to consider the old stuff from before. So it's kind of thinking, well, okay, like we already started off really high to begin with, so we're probably not going to be that much lower from the previous day unless something really drastic happens, right? So this is where we can see like, well, okay, let's do basically subtract off that mean. So we'll see here is that we'll take an average over a certain, like this window, we call it. And so this rolling mean right here, basically, this is the time series data that we already imported in, right? So in our rolling right here, this function says, okay, we're gonna take a window and basically we're gonna consider the last 8 points. And what is the average of those last 8 points, okay? And we'll actually plot off that average. So essentially the way I imagine this, I wish I could kind of like draw a little window, move it across, but I say, okay, we're gonna take these, oops, here we go. We're gonna take these 8 points right here and average them. And then we're gonna take these 8 points right here and average them. And we're gonna take these 8 points right here and average them. I'm making it very coarse, but you can kind of imagine moving this window across and think, all right, these 8 points, that's a new data point. These 8 points, that's a new data point. And this allows us to do a rolling average, okay? And we can also do the same thing with the standard deviation, right? Because we might care about, does the standard deviation, does our variance change over time, right? So it's like, okay, let me see if the standard deviation changes over time. Because every individual point might be a little bit different. But if I average over maybe like a window of data points, we can get an idea of if there's a trend in there. So if I run this now, let me go ahead and get back my cursor. If I run this now, you can see here as I plotted is here's the actual data, the blue, okay? And this is not the same data as this part, but I have this blue data right here, okay? In our time series, and you saw it's exponential. And so we're basically doing a rolling average. So you can notice that the first part is that these first 8 data points or 7 data points don't have that red rolling at mean. And that's because we're averaging over. So there's nothing to average over, right? Hopefully that makes sense. And basically I'm just plotting it against here in this red. And this red basically is representing essentially that average for the, in this case, 8 data points, okay? And you can see here is that we also have in black here the standard deviation. So this is also standard deviation unrelated to the actual value here. But you can see here the standard deviation doesn't seem to be changing too much, maybe a little bit of variety right here, okay? But for the most part, it seems to be relatively consistent, right? Maybe a little bit of some fluctuation for some reason, okay? Now, note that if I make a bigger window, I can basically smooth it out even more. And you'll see here it's a very smooth curve because it's taking now 18 data points. And you can see here that kind of creeps forward. And you can see here, it's very clearly exponential here. And notice that this is kind of interesting. This point right here, this average is going to be lower than this exponential because it's going up very, very quickly. So remember, it's taking the last 18 points. So it's considering this lower part right here. So it's going to drag that times or that graph right there lower down. Okay. So kind of quick gut check. So ignoring about, don't really care about the standard deviation, but talking about mean. If I do a window of 1, what do we expect that red line to look like compared to that blue line? So I'll kind of go a little bit, like if I do 5, right, it'll be a little bit more, you know, bumpy and stuff like that. And if I do something like 10, we expect it to be smoother, right? So if I did 1, like that's a window of 1 data point, right? What would I expect that red graph to look like compared to this blue graph?
The red line would be even more close to the blue one.
So even more close, right? So let's kind of test this out, right? So let's try to do like 5. Oh, you know what? We can do this way. Hold on. I want to see if I can do this right. No, we'll just do it this way. So there's 5. You can see it's really curvy. We try to do 4, even more curvy, right? 3, counting down. Okay, you can see it's even closer to that blue line, like you're saying, Lucy, right? You can see it's more curvy. If I try 2 now, you can see, oh, it's really close. And then that 1, it's exactly on it because it's only taking that 1 data point right there. So it's only averaging on that point. And versus like 2, it's going to consider its point and then the one right behind it. And you can see here, it's pretty close on that case. And you can see the very big fluctuations where it went from up to down on that 1 step. That's when it's really off. But if it's about the same from the previous point, it's pretty close to the point. So the point is that if we make that window smaller, we get more of that fluctuation. And if we make it bigger, we get less of that fluctuation. So a lot of times, though, you don't want a huge window. You want the right kind of size window. And so this might depend on what you're considering. For example, if you're talking about a week, maybe it makes sense to have it over 7 days. If it's over a day, maybe averaging over 12 hours or even 24 hours might make sense. Okay, so cool. So I'll keep it as safe like that. And you can see that change. So one other thing we can do to detect trends is our Dickey-Fuller tests. And so there's some more information about exactly how to use this from stats models. So a good old stats models package, right? And talk about like how to actually do the different arguments in Dickey-Fuller tests. But the main thing that you have to know about the Dickey-Fuller is basically your statistical test to say, is this stationary? So you can kind of think of it as saying, oh, my null hypothesis, is this a stationary trend or a stationary data? And so this allows us to test out, say, hey, how likely is this actually a stationary data set? And so this is where we actually have a coding example right here. And you can see here is basically I import this model right here, this add Fuller. I have the time series data right here. This is the DF test itself. And from that DF test, I can actually say, okay, well, tell me what the p-values, number of lags. I can change this out as I want to. And this is done a little bit more in detail with the curriculum. I'm just kind of quickly showing this part. And I can do a print DF out. And you can see here, I have our test statistic, our p-value, our lags used. And you can see our p-value is 100, which is basically really, really, or I should say 1.0. It's really, really high. Basically saying, hey, this time series is not stationary, which you probably could tell is not going to be stationary. So this allows us to have like that in the same way that a t-test would tell us, hey, is this data related to my population with a p-value and using a p-statistic? You can see, okay, how likely is this, what's it called? How likely is this data actually stationary? So this gives us an extra little tool to use, besides just us looking at it visually. Okay, cool. Any questions? All right, awesome. So that kind of ends up on time a little bit, but I'll say this for next time on, oh, I guess tomorrow, right? We'll talk about removing trends. So actually be able to take something like this and say, let's break it down to components to make it stationary. And then we'll even talk about a little bit of decomposition of saying, well, what can we look at saying what trends are? So for example, if this has some periodic, change over time, but it's also going exponential, we can hopefully separate out those trends directly and say, okay, here's the part that's actually showing it being exponential. Here's the part that's being periodic, which basically allows us to say, okay, well, maybe it's this factor that's causing it to be periodic and this factor to make it go exponential. And for example, if it's the stock market, we really care about why is it going exponential, right? Maybe we can tease that information out. But you can do it for other things too. Cool. Any last questions before I end here? All right, cool. So I'll go ahead and stop recording then.